Okay, number 3. 3A. You have a spring and the spring is extended by 8 millimeters. That means it's 8 millimeters past its natural length. So 8 times 10 to the minus 3 meters. So that's how much it's kind of being pulled down. And this is, well, you know what, I'll draw it the other way around to make it a bit easier. I'll draw it on the table. So somebody pulls this with a 1.5 Newton force, and that causes it to become 8 millimeters bigger. So that's 8 times 10 to the minus 3 meters bigger. Okay, determine the constant for the spring. So if you look back here, I'm sure it's in the formula book too.
F equals K.
Yeah, F equals K delta X, but I want to see if it's in the book. Well, you know it anyways. So we're going to use the formula. The force on a spring will equal K times delta X. And it really should be minus because the spring is pulling back this way. But I won't worry about the minus at the moment. I just know that if there's a 1.5 to the right, then there must be a 1.5 to the left. Otherwise, it wouldn't be balanced and it'd be moving. So you get 1.5 divided by 8 times 10 to the minus 3. That will equal the K. So you have that, what is it?
187.5.
187.5. And the unit is newtons per meter.
But I didn't do that minus. Okay.
No, that's okay. Okay, B part 1.
T equal to
They want the time and the maximum velocity. Okay. So what they've done now is the spring is fastened at one end to a smooth horizontal surface and a mass of 0.6 is attached to the free end. The mass is pulled and released. So you have this spring here. This mass here is 0.6 and somebody pulls this a distance of 4 millimeters. 4 millimeters. And then it's released. So what would happen? It will snap to the left. How much force is bringing it to the left? I'll just write, I know he's not asking for it, but I'm just going to do it anyways.
He's asking
For the time, yeah. But I'm going to do the force anyways, just so you can see it. So the force equals K, and it's a minus because it's going to the left, times delta X. So can somebody type that in, please, and tell me what you get? Andy, MB, do you mind typing this in?
Minus
0.75 newtons. Okay. I know he didn't ask for it, but you know, they could have easily have asked for this instead, so I just wanted to do it for you anyways. Okay, now he actually wants the time. So the formula is in the book. What's the formula? It's 2 pi.
M over K.
Now is it in the formula book like that? Yeah?
Yeah.
Great. M over K. Yep, there it is there. Alright, so that's kind of easy peasy. You just put the numbers in. So it'll be 2 pi root 0.6 over 187.5. So what do you get out for that?
0.360.
0.360 seconds. Alright. And then the next part, that was part 1, and then part 2 is that maximum velocity. Difficult if you don't know how to do it, yes. If you look here, look up here, folks. Okay, you got this? Where is the gone? I'm looking for it. Simple harmonic motion. Alright, I don't think it is in the formula book. So I'll have to tell you what it is, okay? Oh no, it is in the formula book. Look carefully. Let me zoom in a bit. This is the formula for velocity. You see, it's A omega cos omega t. So I'll write that down. So let me just get rid of that. Velocity is A omega cos omega t. Now, can you picture the graph here? This is the graph. Do you remember the graph for cosine? It goes like this. Yeah? So what is the maximum height for this graph here? What's the highest?
1.
No, well, for this whole graph here.
Okay.
No, 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 no.
T.
No, stop saying letters, please, and just think.
A omega x.
What is it?
9.5.
No, that maximum height.
X.
No, stop
Delta.
saying. You're forgetting your maths. Let me go to the side here. All right. So let's switch our brains to maths class. All right. Yes. Dunk. Y equals 4 cos 2x plus 1 plus 3. Okay. So this, if I just had, forget about that. If I just had 4 cos, what's the maximum and what's the minimum?
4 minus
4 and minus 4, right?
4. Yes.
Okay, keep that in your brain, and let's swing back here. So what's the maximum and minimum here? A omega, right?
You said
Now, so the maximum the velocity could be is A omega,
Oh.
right? Now, what's the A represent? That's how much you pull it at the start. Yeah? So what are we told the A is here?
0.004.
4 multiplied 10 to the minus 3. Now, do we have omega? No. But we have this formula. T equals 2 pi over omega. So what does omega equal? 2 pi
times t.
over t.
That's right.
And do we have the t? We sure do. It's 0.36. Okay, so what is that then?
2.26.
2.26
26.
meters per second. So I used this here to give me the omega, and this here is the delta x.
Omega. The one is omega.
Huh?
2.26 is omega.
Andy, give me the final answer, please.
2.26 times 0.004. It's 9.04 times 10 to the negative 3.
MB, please confirm this answer. No, on his calculator. What is it, Andy?
04
Yep.
times 10 to the negative 3.
Are you sure now?
No.
I can do that.
Yes.
It is MB?
Yes.
For sure?
Yeah.
Great.
No confidence.
What?
Not confident.
I have confidence in you, mostly.
Yeah, I did wrong.